Take a close look at a credit card number. 16 digits that seem random. They are not. They hide a self-check that catches your mistakes. It's called the Luhn algorithm, named after Hans Peter Luhn, an engineer at IBM who patented it back in the 1950s. And it runs on the card in your pocket right now. Let's lift that number off the card and run the check by hand, so you can see exactly how it works. First, the very last digit. It isn't part of your account. It's a guard digit, chosen on purpose to make the whole number pass. Now, starting from the right, we take every second digit. These highlighted ones are the digits we're going to double. Here is the only rule. Double each highlighted digit. And if doubling takes it past 9, like 8, which becomes 16, just add those two digits, 1 plus 6, to get 7. Watch them flip. Each highlighted digit doubles, and any that past 9 folds back down into a single digit. Now we add up all 16 digits, the doubled ones and the untouched ones, into one running total. And here is the heart of the whole thing. The question is simply this: is that total a clean multiple of 10? The needle spins and lands on 0. The total ends in a 0. So it is a perfect multiple of 10. The card is valid. And this is the real deal. Your actual card passes this very check every single time you type it in. So watch what happens when you slip and type one wrong digit. A 5 instead of a 4. The total is now 81. The needle spins and misses 0, landing on 1. Invalid. Your typo is caught on the spot. But why is this guaranteed to work? Reason 1. Change any single digit, and the total can only move by somewhere between 1 and 9. And that is never enough to land back exactly on a multiple of 10. So a single wrong digit is always caught. Reason 2 is the clever one. The other really common typo is swapping two neighboring digits. And one of those two gets doubled, while the other does not. So when you swap them, a different digit gets doubled, the total shifts, and the check breaks. It catches every swap but one rare pair, a 9 next to a 0. And that is the Luhn algorithm. A tiny piece of mod 10 arithmetic, quietly guarding every card number on the planet.